Hello, this is a short demonstration of Context Viewer. Context Viewer is a browser-based visual analytics tool for exploring, analyzing, and inspecting context. LLM contexts are typically seen as walls of text that happen to be monolithic or, at best, large JSON blobs. These are seen as opaque and intangible, and they can't be analyzed without pulling them apart. And Context Viewer enables a way of doing that using semantic segmentation and classification. And it converts this sort of a wall of text to something that looks and feels more like data that can be sliced and diced, filtered, grouped, and aggregated so that we can look at it from a few different perspectives and understand it much better. In order to do this, Context Viewer provides a simple pipeline. It first takes the LLM contexts as conversations, parses them, then it segments large messages into smaller chunks, and then identifies a list of topics or multiple lists of topics, and then classifies each of those segments into a topic or more, and then colors them so that we can visually analyze them. Each of these stages internally have a zero-shot LLM call in order to perform the semantic operation. And the user has control over each of those prompts. And so they can iteratively modify these prompts in order to guide the exploration in the direction that they want. In order to demonstrate Context Viewer, we will take up the example of context compaction of a simple Claude code transcript. This is a session where I implemented a feature called multidimension, and we have the transcripts before and after compaction. So I will just drag them and drop them into Context Viewer. Context Viewer will take the conversations, count the tokens, parse them, and then run through the pipeline. In the meantime, we can have a look at the contents of it. You can see that this is mostly text, and it's not a trajectory. So the post-compaction is actually just a summary. And pre-compaction will be the trajectory with assistant and tool messages back and forth between the model and various tools. Since it has automatically componentized them or identified the topics, we can see what the topics are. These are related to code-based exploration, architecture, and some UI implementation, and some bug fixes, etc. You can also see the actual trajectory in sequence. So it mostly started with the grays, which are the code-based exploration, and the blues here, which are the feature building, and then there's a refactor that's purple, and it seems to have compacted after that with some git commits before it did that. We can look at the same thing for the post-compaction, and here it has a list of pending tasks. It has the actual feature that we built, right? And at this point, we can refine the categories a little bit because we understand it a little better. So we edit the component identification prompt or the topic identification prompt and ask it to find topics like these because we have a better understanding and we can find more refined topics. And it has found them, and these are slightly different now and a little easier visually to look at. These are like code-based exploration, tool calls, and git commits. That is not a particularly useful categorization. There's the workflow pipeline, there's the UI development, etc. And at this point, I think we have enough confidence to narrow down these categories to a smaller list because as we can see, we go from 20% to a long tail very quickly, and we want to group a lot of these categories into smaller categories, into the larger categories. And so what we can do is we can edit the components and provide the components ourselves. And these are a list of components that I came up with earlier for demonstration purposes. So I've edited the components in the post-compaction summary. I will provide the same components in the pre-compaction as well. And once both of them are done, we can just group them and compare them side by side and sort them by the token, right? And here we see pre-compaction is primarily code-based exploration, so 70%. And then there is UI implementation. And then on the other hand, post-compaction summary does not have much of code-based exploration. It's much lower at 8%. And then task management shows up as a higher amount. It's also possible for us to go here and then take out code-based exploration so that we can see what the waffles look like afterwards. And here you can see that they are a little closer with task management still showing more here. So if you wanted to see what these things are, we can just go in here and filter it to only task management so that we can see that these are indeed task management about problem solving and some user messages and pending tasks. Yes, and so with this, we can see that Context Viewer allows us to compare how categories have changed before and after compaction. That code-based exploration has been compressed, and there are more tasks in terms of handovers which are expected post-compaction.